So, hello and welcome to another video from sickmaths.co.uk, where you can find the whole of GCSE Maths explained on video, all for free. This video is about Pythagoras' theorem and midpoints. There's a tiny bit right at the end about midpoints, but really about Pythagoras' theorem. So there was this bloke called Pythagoras, and he had a theory or an idea, okay, and this is his idea. Basically, if you have a right-angled triangle, and this only works with right-angled triangles, you can work out one of the sides of the triangle if you know the other two. So that's the idea, and this is how it works. You have to find the biggest side first of all of the triangle, call the hypotenuse, but you don't have to worry about that really. It's just nice to know. So you find the biggest side. This is the biggest side, and I know it's the biggest side because it's opposite the right angle in this triangle. Okay, so they're opposite. These two are not opposite, are they? The one that is opposite is the biggest side. So the biggest side, okay, the length of it squared is equal to the length of the other sides squared and added together, and that's it. So I suppose that sounds a bit complicated, so let's write it down in maths. It's really short in maths, it's just this one line. Okay, so this side squared is equal to that side squared plus that side squared, as it says here. So you get y squared equals 8 squared plus 6 squared. 8 squared is 64, 6 squared is 36, so therefore y squared is 64 plus 36, but 64 plus 36 is 100, so y squared is 100, and therefore y must be the square root of 100, which is 10. Now some people might go, oh well, the square root of 100 is also minus 10 as well. So why don't you write y as minus 10? Well, y is supposed to be the length of this side. So to say that it's minus 10 doesn't really help. So we just use a positive square root. So basically we've worked out y. The length of y is 10. 10 units, whatever it happens to be. It could have been, if it was all measured in centimeters, then we would have said 10 centimeters is the length of this longest side there. Let's do another example. This time we've already got the biggest side. The biggest side is 5 units, so if we write 5 squared is equal to 3 squared plus x squared. Okay, so we're trying to work out one of the smaller sides. We don't know how small it is, but we're just trying to work it out. So we write it exactly the same way. We don't have the letter first, just because the biggest side goes first, yep, and the letter happens to be one of the smaller sides we're working out. So you write 5 squared is equal to 3 squared plus x squared. So 5 squared is 25, 3 squared is 9, and x squared is still just x squared. So we've got this now, and we're trying to work out what x is. So eventually we want x by itself. So we're going to move the 9 to either side to get 25 minus 9 is equal to x squared. This is a very simple equation trick. If you don't know that trick, just go to my website here, sickmaths.co.uk, and just go to the basic equations video on the website. Okay, now 25 minus 9 equals x squared, therefore x squared is equal to 16. Notice I swap it round because I like the letter to be on the left side at the end of the answer. So x equals therefore the square root of 16 if x squared is 16, which is 4. And that's it. So we've worked out this length is 4 units, whatever the unit happens to be. Let's do a bit of Pythagoras in 3D. So you've got a cuboid here. Okay, so as you hopefully would have guessed by looking at it, and so it's a 3D shape. And what do we want to work out? The length of AC. Find AC, it says. So this length from here to there, which is basically going across the floor of the cuboid. Okay, now if you look carefully, what you've got on the cuboid, the floor of the cuboid is a rectangle, and if you cut halfway through the rectangle, you get a nice right angled triangle. Can you see that right angle there? It's quite hard to spot. Okay, so you've got a triangle there, 3 sides, and I've just redrawn it here. So you've got ABC. ABC, just so you can understand roughly what's going on. Okay, so you've got a right angle triangle there. Now this bottom length, A to B, is 3 units, and B to C is 4 units. So basically you've got a right angle triangle where this is 3, this is 4, and we want to work out length A to C. Okay, so you say this side squared, AC squared, is equal to 3 squared plus 4 squared, as it says there. And again, we do the usual working out, simplifying each bit. So 3 squared is 9, 4 squared is 16. So therefore, AC squared is 9 plus 16. 9 plus 16 is 25. So AC squared is 25. AC must be therefore the root of 25, which is 5. So we've worked out this length from here to there is 5. Okay, now somebody might be confused, just a little bit confused possibly, if they saw AC squared. They might think, oh, that means A times C squared. No, it just means the length AC is squared. Okay, now you're allowed to do that in maths. Okay, don't worry about that. Anyway, so what's the next thing we need to do? We need to work out length A to D. In part B of this question here, we want to work out A to D. So A to D is from there to there. It's going right diagonally right through the cuboid. Now also, because we're doing Pythagoras, we're going to use Pythagoras to work out this length here. Okay, and again, since we're using Pythagoras, we need a right angle triangle. So again, I've drawn it for you. There's a right angle triangle going from A to C, and C to D, D to A. There you go. Hopefully you can see it. Okay, and the right angle is in that corner, which I've drawn there. Now, to find A to D, we need to know A to C and C to D already. Now, as you normally get in the GCSE Maths exam, Part A often helps with Part B. So in Part A, we worked out A to C was 5. And then C to D we already know is 12 units, as it says there. So basically, as we were saying, A to D squared is equal to A to C squared and plus C to D squared. Now A to C squared is 5 squared, C to D squared is 12 squared, as it says there. So, and 5 squared is 25, 12 squared is 144, so therefore AD squared is 25 plus 144. That adds to 169, and therefore AD must be the square root of 169, which is 13. And finally, for our last example, we're going to find the distance between coordinates. Okay, so you pick any two coordinates. I've picked 3 to 5, 7 to 8, and I'm going to find the distance between them. Okay, and here's the idea behind it, so you can understand how to find anyone. Let's quickly draw a picture here, just to get an idea of what's going on. So roughly make a mark 3, 5, and 7, 8, which means this coordinate is 3 across, okay, and 5 up, as you can see here, and this coordinate here is 7 across and 8 up, as you can see there. Now the reason why I marked these especially is to show you how I can use Pythagoras to work out the distance between them. Okay, all I do is draw a right angle triangle, and I can see the distance across from here to there is 4 units. The distance between 3 and 7 is 4, isn't it? So I can say, if I make a right angle triangle, it's going to be 4 wide, okay, and it's going to be 3 tall, because the distance between 5 and 8 is 3, okay, because the distance it goes up from here to, from there to there is 3, as shown over here. So basically it's going 4 across, 3 up. Again, we do Pythagoras. Okay, so x equals 4 squared plus 3 squared, square rooted, basically is 5. Now, I don't expect you, or you shouldn't really, have to draw this picture every single time. You should understand the idea. The idea is really, we find the difference in the x values, like we did here. So we do 7 take away 3, okay, to get that number, and we do 8 take away 5 to get that number, and then you square each of those answers like you did in Pythagoras to get the square of the actual answer, and then you square it at the end. So basically all you need to do is 7 minus 3 squared plus 8 minus 5 squared. Okay, get that answer and then square root it to work out the value of x, which is the distance between the coordinates, which is 5. So the distance between the coordinates is 5. Now at the very end we're going to do work out the midpoint of 2 coordinates. Since we're talking about coordinates and stuff already, why not finish it off with this topic here? very quickly, what's going on is that you're finding the average of the two coordinates, because what you really want to do to find the midpoint of these two coordinates, you want to go halfway between here and there, across and upwards. So you want to go halfway between 3 and 7, and halfway between 8 and 5. Now how do you find a number that is halfway between 3 and 7? You simply find the average, the mean average, I should point out. Yeah, so you basically add those two numbers together, divide by 2, you get the number in between, which is 5. Okay, you add these two numbers together and divide by 2, and you get 6.5. So you have to go 5 across and 6.5 up to find the midpoint, and you find that's the midpoint. Okay, so we call the midpoint M, just in case you're getting confused, which we wrote over there, and that's it.